All right, ladies and gentlemen, let's talk a little bit about one of the last few sections I think that we deal with in terms of areas and whatnot. And today we're going to talk a little bit about what's called geometric probability. So, geometric probability is a form of normal probability. And if you guys recall, when you talk about probability, you're talking about probability of some what's called of an event occurring. For example, if I want to talk about what is the probability that I could roll a 3 on a regular single-sided die. So what we would look for is we look and see if we can find a die real quick here. I take a die. And what I want to think of is the probability that I can roll a 3 on this die is, well, how many possible ways can you roll a 3? Well, the way that that happens is that there's only one way you can get a 3. You just get a 3. And then you divide that by the total possible outcomes. Well, on a die, there are 6 sides, so the probability that we can get a 3 is 1 out of 6. So the way that this looks is the probability of an event is going to equal the number of ways the event can occur, can happen, what to say, over total possible. So if you think about it this way, if I wanted, like I said, when I wanted a probability of rolling, let's say we'll roll an even number. Well, on a regular sided die, there are 3 even numbers, so 2, 4, and a 6. So there's 3 out of the total possible outcomes of 6, which would be 1/2. So what happens here is with probabilities, we're always going to be dealing with a fractional amount. Because what happens with that is that you have a range of possibilities, it's called. So probabilities of some event are always going to be between 0 and it'll always be between 0 and 1. If the probability is 0, it means it's not going to happen. And the probability is 1 is it's going to happen. For example, the probability that you have homework is 1, because I'm going to assign you guys a couple of problems of this stuff. So that means that if you ever get a probability that is greater than 1, it means you're wrong. If you get a probability that is less than 0, you are also wrong. So your probability will always be somewhere between 0 and 1. So where does this come into when you deal with geometry? Well, what happens is we talk about what's called favorable regions. We talk about favorable area. And we're going to start looking at things in terms of, let me get my marker back on here. We'll start looking at probability of what we're going to call shaded regions. So if I want to figure out what's the probability that I land in this shaded region, well, I have to figure out what the favorable area is of the shaded region divided by the total, forgot the L, the total area. So what we look at here in this example, we have 2 rectangles, okay? The rectangles we have a large rectangle that is 6 by 12 and a small rectangle that is 3 by 8. This shaded region in here is taken up by the large rectangle, the 6 by 12, and you have to cut out the whole of the small rectangle of 3 by 8. That is your favorable region. The total area is the big shape. It's just the 6 by 12. Okay? So from here, we would have to go and start using our calculator. Well, let's see. I think I have a calculator here. I'll move this over here. To get the numerator, we just type it in, 6 times 12. Subtract 3 times 8. And there's my numerator, 48. Oops, I'll turn my thing back on. And then the denominator is the 6 times 12, which is 72. I'll show you anyway. Oops, wrong button. And we get 72. Which means my last bit to do is to simplify that fraction, which, once again, go back to my calculator, 48, fraction bar, 72, and hit enter. And the probability of landing in that shaded region is 2/3. Okay? Area of the favorable divided by the total area. So you're going to be working with all the different area formulas that we've worked through over the course of the past couple of weeks. So I hope you have them all in one sheet of paper. If not, I'd go make sure that you have them all in one sheet of paper. Let's look at another one. Oh, we did this one. Same basic idea. Let's find the probability of landing in the, I'm sorry. landing in the green. Excuse me, I put that in the wrong spot and wasn't paying attention. I want to see what's the probability of landing in the green section. So what we would start with is to find the area of the green section. We have to figure out, well, that area is a rectangle subtracted out by another smaller rectangle. So again, same thing. We have 36 times 12, subtract out the 22 times 8. The total area was the 36 by 12. Now, as we get going into these things, you should be able to put this stuff together. If you type this in with fraction bars and parentheses, you might be able to make this work with one. Oops, sorry about that. Move this over just a bit here. So let's clear this up. Let's do a fraction bar. And we've got 36, parenthesis, 12, close it, subtract, 22, parenthesis, 8, close it, and go to the denominator. And then we have 36, parenthesis, 12. So if you have a multi-view calculator, I would go ahead and type it in this way. Well, as soon as you write it out, then you just hit to your calculator, and then your probability of landing in the shaded region is 16/27ths. It's okay to have, we don't need decimals here. All we need to do is just give me a fraction that's simplified. Okay, let's try, I think I have one more here. Probability you want to land and hit in the circle. So the circle is encompassed by this would have looked a little bit easier to see on the smartboard, so I apologize for not being as clear here. But we have a 12 by 12 square and a circle that's inside. And I want to land inside the circle. So the favorable region here is the circle itself. So the area of the circle, so we have the area of the circle, and then we have to divide that then by the total area, which is the area of the square. So this would be 6 squared pi divided by 12 times 12, because that's how we get the area of the square. So go back to our calculators. Move this over here for right now. Go to a new, clear it. I'm going to go to a new fraction bar. 6 squared pi over 12 times 12. Now, with some of these things we're dealing with pi, sometimes it might give you an answer in terms of pi, sometimes it might give you a decimal. In this case, it gave me the answer in terms of pi, which is pi over 4. Now, if you're not sure if that's actually a correct decimal, if it's less than between 0 and 1, just hit the double arrow button, and you'll see that it is between 0 and 1. You should be okay. I don't think we have to do that. So I left for you guys, I believe there are 6 of them. Remember, you're going to want to find the probability of, we're looking at just shaded regions here. So you have to figure out what is the favorable area and then divide it by total area. So it'd be favorable area over total area. Okay. Make sure you have your formula sheets with you as you're trying those out. Also, show your work as you're putting these things together. That way we can make sure that you're using the correct formulas and you're substituting it in correctly and pressing the buttons right on the calculator. So, if you got any questions, shoot me an email, and we'll talk with you guys soon. Thanks.